Hey guys, so I'm recording this. Why am I recording it? It's because there are people on the college bus tour, and so I promised them that I would record it so I could put it on YouTube for them. We are learning about geometric sequences today. You guys should have already known they were coming because right beside your arithmetic sequences on the formula sheet, you see geometric sequences. So you got one, you know the other one is coming. A geometric sequence or a geometric progression is a sequence which the ratio of any two consecutive terms is constant. This constant is called the common ratio. And to illustrate in a geometric sequence, 1, 3, 9, and 27, each term is 3 times the preceding term. So that is the common ratio. 3 divided by 1, 9 divided by 3, or 27 divided by 9 is 3. So in other words, in an arithmetic sequence, we always added to get to the next number. We always added the same number to get to the next number. Now we're going to multiply by the same number to get to the next number in the pattern, as we wanted to call it. In general, the common ratio R can be found by dividing any terms in the sequence by the preceding term. And so R can be found by saying a to the n plus 1 divided by a to the n. I'm going to pause it for just a second for everybody to write this down. Sorry, when I pause it, you can't see what's in the middle. It's a to the n plus 1 over a to the n. Like a to the 5th divided by a to the 4th. Whatever the larger term divided by 1 less. If you take your a to the 7th term and divide it by a to the 6th, you're going to find your ratio. Take one larger divided by the one previous to it. That's always going to give you your common ratio, what you're multiplying by. So you've already got your fabulous formula right in front of you. So let's start looking at a couple of types of problems. It says write the first 6 terms of the geometric sequence with a first term of 2 and a common ratio of 5. So if your A1 is equal to 2, your A2 is going to be 2 times 5, which equals 10. Your A3 is going to be 2, well, sorry, it's going to be 10 times 5, which is 50. Your a to the 4 is going to be 50 times 5, which is 250. Your a to the 5th is going to be 250 times 5, which is 1,250. And your a to the 6th is going to be 1,250 times 5, which is 6,250. Now what I want you to see is where your formula comes from, is that this is your A1, your A2 is equal to your A1, and your 5 is your common ratio. And what do we use to represent our common ratio? Times R, right? Common ratio times R. So how many R's do we have here? We have one of them, right? If we have a 2, this is a 2, right? That's why we have to have the n minus 1. Does that make sense? That's why we have to have the n minus 1, because we only need r to the first. If we look at a to the third, we've got 10 times 5. Well, what was 10 actually made up of? It was made up of a 2 times a 5 times a 5. Everybody see where that comes from? So that's actually an A1 times an R squared, right? Which is our formula of A1 times n minus 1. If we look at a to the 4th, this 50 is 2 times 5 times 5. And in order to get our a to the 4th, we have to throw in our one more 5, right? See where that's coming from? So our a to the 4th is A1 times R to the 3rd. I just want, some of us like to see where that formula actually comes from. So you see the connection there? So that's where this A1 times R to the n minus 1 is coming from. I think it's pretty cool. You take that 2 times 5 times 5 times 5 and plug it in down here. We've got 1, 2, 3, 4, and then we get one more, right? That gives us our a to the 5th equals A1 times R to the 4th. Okay. Write the general term AN of the geometric sequence of 3, 12, and 48. Well, the formula that you all were given, and it's right there on your sheet, is that A to the N equals what? A1 R to the N minus 1. So my AN equals, what's my A1? 3. And then I always put parentheses around my R to separate the two of them. What is the ratio? What am I multiplying to get from 3 to 12 and then from 12 to 48? 4. So it's going to be 4 to the N minus 1. If you're not sure, you can always say 12 divided by 3 equals 4 and 48 divided by 12 equals 4. And that's it. That's what we're looking for. That's our general term. That's our relationship. And what type of relationship is this? If we wanted to describe this type of relationship, a geometric, the last type of relationship, arithmetic, how do we describe it? How did I describe it? What type of function was it? Linear. Good, Nick. What type of relationship is this? What, Luke? It's going to be exponential because where's my variable? In the exponent. That n is in the exponent. What's happening to these numbers? 3, 12, 48. Look at this. Look at this last example. 10, 50, 250, 1,250, 6,250. What's happening to them? They're growing. They're shooting up. They're getting huge, right? They're growing exponentially. This one says find the sixth term of the geometric sequence with a first term of 3 and a common ratio of 4. So let's start with our formula of A to the N equals A1 times R to the N minus 1. We want the sixth term. So we're going to start with the first term of 3. Our common ratio is 4. And we're going to plug in what for n this time? So it's 6 minus 1. Using order of operations, what do I do first? So I have to simplify that to 5, right? What's 4 to the 5th? What do you get? Well, I got 1,024. And then times 3. 3,074. Oh, I don't know where I got a 4 from. You're right. 3,072. I guess I was looking at that 4 and not the right thing. Oh, I was looking at the one before. You're right. Thank you, Soraya. You keep me honest. Alright, so the sixth term would be 3,072.